Good morning and welcome to all of you. In today's class, we are going to discuss about the magnetic force. First of all, the magnetic force on a point charge. Assume that there is a charge of 2 coulombs which is moving in this direction with a velocity v. Assume that it is moving in the xy plane. And when this is subjected to a flux density, magnetic flux density of B, let theta is the angle between V and B. What is the magnetic force on this point charge which is moving with the velocity v? The magnetic force Fm is equal to qv cross b. So the magnitude of the magnetic force is equal to q into v into b sine theta. What is theta? Theta is the angle between v and b. What is the direction of the magnetic force? Perpendicular to the plane containing V and B. So if you want to find out what is the exact direction, turn the screw from V to B. If I turn the screw from V to B, it progresses along positive Z direction. In this case, it is going to be positive Z direction. Now let us extend this theory to find out what is the magnetic force on a current element. Magnetic force on a point charge is equal to qv cross b. Okay. Now, what is the magnetic force on a current element? Assume that I got a conductor of length dl carrying a current of I. So, IDL is the differential current element. When this is subjected to a magnetic flux density of B, what is the magnetic force? Now, you can see that uh, when current is moving along this direction, assume that in a differential time of delta t or dt, the charge has moved through a distance of dl. So dl by dt is the velocity of this current or charge. Now let us go back to this expression. Differential force on a differential charge dq is equal to dq v cross b. dq, what is the velocity when the charge is covering a distance of dl in a span of dt time? So velocity is nothing but dl by dt. So dq dl by dt cross b. But what is dq by dt? It is current I. So I into dl cross b. So ideal cross b is a differential force on a differential current element. Now let us discuss about what is Ampere's force law. Suppose there are two conductors carrying currents of I1 and I2 respectively. The current is, let us say, flowing in the positive Z direction. I1 is flowing in the positive Z direction. I2 is also flowing in the positive Z direction. Now let us say, will there be any attractive force between the two current carrying conductors, or will there be a repulsive force? Now if you look at the situation, let B1 is the magnetic flux density created by the first conductor carrying a current of I1. B1 is the flux density at this particular point where dl2 is defined. Okay. Created by the first conductor. Because the conductor 1 is carrying a current of I1, it creates a magnetic field. So let B1 is the flux density created by the conductor which is carrying a current of I1, where at point 2 where I am defining dl2. So now through the second conductor I2, through the second conductor, a current of I2 is flowing. So what is the differential force on the differential current element dl2, which is carrying a current of I2 because of this B1? df2 is equal to I2 dl2 cross B1. I2 dl2 is the differential current element and B1 is the flux density at dl2, which is created by the first conductor. So now, assuming that the first conductor is of infinite length, it creates a magnetic field of H1 is equal to I1 by 2 pi d A5. So what is B1? Mu naught into H1. So mu naught into I1 by 2 pi d A5. So let us substitute here. df2 is equal to I2 dl2. What is vector dl2? What is the direction? Direction is az, because I2 is also flowing along the direction of az. So dl2, the direction of dl2 is nothing but the direction along which the current I2 is flowing, az into B1. What is B1? Mu naught into I1 by 2 pi d A5. So AZ cross A5. AZ cross A5 means it is going to be minus 0. So there will be attractive force which is equal to mu naught into I1 I2 dl2 by 2 pi d. So the differential force per unit length df2 by dl2 is equal to mu naught I1 I2 divided by 2 pi d. It is an attractive force. It is an attractive force. Suppose if I1 is flowing in the positive z direction, if I2 flows in the reverse direction, negative z direction, then you will get a repulsive force.